This is Learning Assessment Problem 313. In this problem, we are to use a problem-solving strategy of loop or mesh analysis. In this problem, we are to use the problem-solving strategy of loop and mesh analysis to determine the voltage V sub O in the circuit. In the mesh equation approach, we'll be solving for currents. We'll label these mesh currents I1 and I0. And in order to determine the voltage VO, we'll use an auxiliary equation that VO is equal to IO times 6K. As we recall, in doing the mesh analysis, we'll be applying Kirchhoff's voltage law and summing voltage drops around the loops or meshes. We'll label the polarities of those voltage drops around these loops, obeying the passive sign convention for the indicated loop currents. So if we do a Kirchhoff's voltage law summation around the mesh I1, we'll have 2K I1 plus 4K I1 plus 2K, and then the difference of the two loop currents I1 minus IO plus 3 volts equals 0. Rearranging, we have 8K I1 minus 2K I sub O is equal to minus 3 volts. We'll call that our first mesh equation. And similarly, we'll do a KVL around the mesh current I sub O. Have 6K I sub O minus 3 volts plus 2K times the difference between the two counterflowing currents IO minus I1 minus 6 volts is equal to 0. Rearranging again, we have minus 2K I1 plus 8K IO is equal to 9 volts. And this we'll consider as our second mesh equation. We write this in the matrix format. We have 8K minus 2K minus 2K 8K. This is our resistance matrix. The two currents I1 and IO. And that's equal to our voltage matrix, minus 3 volts, 9 volts. We can solve for the one current IO equals 11 tenths of a milliamp. And now we can go to our auxiliary equation. VO is equal to 6K IO is equal to 66 over 10, which is equal to VO is equal to 33/5 volt.